As we finish up, Simon, I'd love to understand, kind of your vision. What do you think the future of genomics will look like?
Well, that's either a loaded question or a transformative question. I think it has to be multimodal. I think, we have to look at the translation of, instead of unimodal approaches to understanding the mechanisms associated with disease development and progression, we have to have this sort of multi-omic approach. My move to neurosurgery most recently coincided with me starting a program in neurosurgery. It's the brain tumor omics program. So what we're trying to do with BTOP is really, as I said, integrate these multi-omic modalities. So if you think of the genomics, transcriptomics, epigenomics, proteomics, metabolomics as being these horizontal omic modalities, and we want to vertically integrate them across cohorts to try and use the power of each of these omic modalities to have a more informed understanding of disease development and progression, and just sort of make not just novel discoveries, but translational discoveries where we can identify potential novel therapies, the impact of different treatments in the context of brain tumors, but then also integrate modalities that we haven't thought of before, such as digital pathology, AI means of diagnostics, empower the diagnostician, if that's the word, so the pathologists or the clinicians at the coalface of interacting with patients, understand better the diagnosis of disease development and progression. So I'm really, really excited by what omics and genomics specifically are going to deliver in the next 3 to 5 years. I think it's going to be a very rapid improvement in what we can do.
No, that's great. I think the power of big data, both on the imaging clinical side as well as what you do on the omics side, and pairing those through team science, right, is how we're going to really be able to personalize how we take care of patients.
Absolutely. Yep.